In this lecture, we shall discuss FMEA, failure mode and effect analysis, a very critical tool in lean deployment. We shall discuss the philosophy of FMEA, why it's needed, and how it's done. So, what is FMEA? FMEA is an engineering reliability tool that provides a mental discipline when critiquing what might go wrong with the product or process. FMEA helps define, identify, prioritize, and eliminate the known or potential failure modes of the system, design, or manufacturing process before they reach the end customer. It could be the end user or subsequent operation step. FMEA is a living process document which helps prevent and not react to problems. The FMEA thinking has been around for hundreds of years. It was first formalized in the aerospace industry during the Apollo program in 1960s. Apollo was a very popular space program of the United States. The initial adoption in the automotive sector happened in the 1970s, and today FMEA as a reliability tool is adopted by many industries across a variety of business sectors. So, what are the basic elements of all FMEAs? The first step, obviously, is a proper planning of the FMEA. Having a proper cross-functional team is critical to the success of FMEA. Team should be comprised of members coming from manufacturing, product design, engineering, quality assurance, procurement, and customer service. You review the process, design, product, and the service aspects. The second step is you identify the potential failure modes. You identify the potential effects of the failure modes. How severe are the effects? You identify the potential causes of the failure modes. You identify and assess the current controls of the failure modes. The fourth step is interpretation of the failure modes, the severity, the occurrence, and the detection, which shall be explained subsequently. Then is the follow through step, wherein you take actions to reduce and eliminate the high risk. Finally, you repeat the process again. The FMEA process steps, let's read them together. The first part is the planning or the preparation phase. Here, we review the process, design, product, or service aspects. This part should be done in great detail. Thereafter, we identify the potential failure modes. We identify the potential effect of each failure mode and assign a severity rating for each effect. Then, we identify the potential causes of each failure mode and assign an occurrence rating for each failure mode. Thereafter, we evaluate the current process controls and assign a detectability rating for each failure mode, which is how easily you are able to detect or not able to detect the potential failure mode. Thereafter, you prioritize the failure modes. Here, a factor which is called RPN number is used. RPN stands for risk priority number. This factor is a multiplication of severity rating multiplied by occurrence rating multiplied by detectability rating. It gives you an understanding of the level of risk you face at each failure mode. The higher the number, the higher the risk. Thereafter, we identify and implement actions leading to improvement, which is risk reduction. Here we take action to eliminate or reduce the high risk failure modes. Then comes the reassessment, which is we reassess the risks with another FMEA cycle. Let's now try to understand the FMEA rating scale. That is the rating scale applicable to the different parameters, the severity index, the occurrence index, and the detectability index. Severity scale, a rating of 10 indicates the effect of failure mode is very serious, such as hazardous effect without any warning. As we go down, the severity of effect comes lower. So a rating of 1 implies there is basically no impact. Similarly, for the occurrence scale, a number 10 indicates that the likelihood of occurrence of failure mode is very high and the failure is almost inevitable. Whereas as we go down, the number 1 indicates that the occurrence is likely to be remote and the failure is unlikely. Similarly, for the detectability index, a rating of 10 indicates that the failure mode is not likely to be detected. We don't have process controls to detect the failure. And as we go down, the number 1 indicates that it is almost certain to be able to detect the failure mode. The risk priority number is a factor which is a multiplication of the severity number, the occurrence number, and the detection number. It will always be between 1 to 1,000, and the lower the number, the lower the risk. The higher the RPN number, the higher the risk. This pictorial is a good illustration of the FMEA process schematic, starting from reviewing the process, identifying the failure modes, assigning the severity ratings, the occurrence ratings, and the detection ratings, and calculating the overall risk score, which is called the risk priority number or RPN, and then taking the actions to reduce the risk and repeating the cycle again. The recommended actions, the focus of FMEA analysis is always on reduction of the risk priority number or RPN, which gives you an indication of the level of risk at each of the failure modes. This RPN number can be reduced by lowering any of the 3 ratings, severity, occurrence, detection, either individually or in combination with one another. Reduction in the severity rating is generally the most difficult task. It requires a physical modification of the process equipment or layout. Reduction in the occurrence rating is generally the most desired task. It can be accomplished by removing, mitigating, or controlling the potential causes of failure. The reduction in the detection rating is also desired. It is accomplished by improving process controls in place, could be alarm signals, or sensors. After taking the appropriate actions, you review and update the severity, occurrence, and detection scales and reevaluate the RPN number. The action plans in the FMEA should be taken very seriously. If ignored, you have probably wasted a lot of your time. If accomplished well, you will gain significant gains. This is an illustration of a basic FMEA template. You can design your own template. This is just an example. The first step is, what is the process or input step under investigation? Then we find out in what ways the key input can go wrong. That is, what are the failure modes? Next, we find out the impact on the key output variables, that is the effect and the related severity rating. Next, we determine what causes the key input to go wrong, that is the causes, and the related occurrence rating. Then we determine what are the existing controls that prevent either the cause or the failure mode, that is the detection rating. And finally, you calculate the RPN number. Next, you take the requisite actions to reduce the risk. And then the steps are repeated again and the RPN number is re-evaluated after your risk mitigating actions. Hope you find this FMEA template to be useful when you carry out FMEA process in your own industry. Let's look at a practical example of an FMEA. This is an FMEA for a toaster. One of the potential failure mode is that the power cord could get short, so the toaster is not working. The effect of this is fire. The severity rating scale is 10, which is maximum, that is hazardous effect without any warning. The potential causes could be rough handling of toaster during shipping to the customer or warehouse. The occurrence rating, therefore, is say 7, which is high. The current controls are none, so the detection rating is 9. That is very remote chances of detecting. So your initial RPN score is 10 multiplied by 7 multiplied by 9, which comes to 630. Indeed, quite a high RPN score. Thereafter, you take some actions to mitigate the risk, such as deploying better packaging. In this particular example, the severity, however, remains the same because in case of failure, the effect will be fire. It is not going to change. So the severity remains 10. However, the occurrence of failure reduces significantly due to better packaging, so the occurrence rating is reduced to 2. And maybe now we have also deployed some better detection controls. So the new detection rating improves to 5, which is moderate chances of detection. So after your actions, the RPN reduces to 10 multiplied by 2 multiplied by 5, which comes to 100. Indeed, an improvement from an initial RPN score of 630. However, you may still be able to reduce this RPN number further by deploying much more sophisticated detection controls like fire alarms, smoke sensors, temperature sensors, and interlocks. So the detection rating could be improved further and thereby your RPN score.